use a partial cookie injection and turn it into a full cookie injection where we control the key too. Just with like a partial cookie injection. So you'll need to inject 3 cookies, right?
Matan, what are you doing, man? What's up, guys? This is a continuation episode of last week. The topic is not related at all, but it was something that we planned to put into one episode, but we just didn't quite fit it in time-wise. So this week, we're going to be talking with Matan again about some cookie-related quirks, potentially how to convert a partial cookie injection into a full cookie injection, and some other quirks around browser parsing of cookies, and the amazing caching-related write-ups from Kevin Mizu with the HeroCTF. So hope you guys enjoy this episide. All right, man, here we go. We're back.
Yeah, a new episode.
our poor editor. I can't put too much strain on him because that was a long episode, as we always do. But yeah, let's definitely. I definitely still wanted to get to some of these awesome things you had in the doc here. So let's hit the 2 cookie pieces, and then we'll go and talk about the caching stuff.
That first cookie trick I love. That's really mind blowing and super useful. Yeah. So in certain environments. Specifically, I've looked at Java environments just because that's like what my targets used at the time. But they have a pretty weird cookie parsing logic, especially when it comes to quotes. So what they have is basically a way to have a quoted value of a cookie. So if there's some character that would normally be problematic in the value of a cookie, like semicolon, what they do is they put quotes around the value of the cookie. So you have like key equals value in the cookie. You can have, what they do is they have key equals and then quotes around the value. And then even if the value has like weird characters, it will parse it correctly.
Correctly. So, in not compliant at all with the RFC.
Yeah, like that. I mean, I haven't read the RFC, so maybe it's compatible. I'm not sure.
It's a legacy thing from an older version of the RFC. Yeah.
Interesting. So it was correct at some point.
It was.
Anyways, it might be correct. It's exploitable. Okay. The scenarios where it's exploitable is one, in those environments, okay, you might have a scenario where you want to comment cookies, okay? And what I mean by that is, say you want to exploit the sort of self-XSS, like we mentioned in the previous episode that you had with me.
Yep.
So if you want to exploit that in a Java environment, a lot of the time it's problematic because the value that these environments prefer is sort of the latter value. If you have 2 cookies with the same key, they'll prefer the latter one and not the first one, it's like usually happens. And it's very hard to get your malicious cookie to come after the legitimate cookie. So what you can do, if you wanted to prefer your value, so to do what's called cookie tossing, if you have a way to set cookies in the target, you can set all of your cookies that you want and then set like as the last cookie, a equals quote. And now it will read everything after the a cookie, unless those cookies have like quotes in them, which is gonna mess up stuff because then it will close your quote, stuff like that. Very annoying. I had to deal with that a lot the last time I tried to exploit it.
Yeah.
Man, it was crazy. I like started shifting the order of the cookies, stuff like that.
Well, it's tricky, right? Because and I'll just talk about this for a second. The order of the cookies is determined by the path length first, right?
And the chronological order.
The chronological order,
of setting
right?
it.
So if you're setting it super recently, like if you're getting it set,
it's
then
not even
it's
the
gonna
original time it was set. It was the last time it was set. So if they change the value, it's sort of a reset.
Yeah. So that's helpful to exploit. But what I didn't realize before I was prepping for this episode was that this is, for some reason I had it in my head that the order was not just based on the path link. It was ordered based off of like some other thing, like alphabetical or something like that.
I looked for that desperately. I couldn't find any other.
And it's not. It's literally just the path link. So if you want your cookie to come first, the very, very first, all you have to do is just set a very, very, very specific path link.
Yeah.
And dude, I spent I always tell myself, all right, I'm just only going to spend like a couple hours prepping for the episode, and then I'm going to like get along with my life. No, because what happens is you get in these scenarios and you start researching this stuff, and then you're like, wait a second, I need to go see if I can figure out a way to artificially inflate the path size so that it on a cookie, so that you can force it to the front, even if you have another cookie that has a very explicit path set.
But you can always be more specific. You can pick like all of the endpoints that you're trying to exploit and set like a different cookie for each of those.
Yeah, unless the actual endpoint, the actual business logic also sets that.
That's gonna be very like setting
it is.
For a specific endpoint. It's gonna be very.
I have seen it before, and so I was looking into this, and I couldn't figure it out, except for one nice little nuance, which is oftentimes web servers will decode the %2f in the URL, right?
Oh, so it resets it?
Yeah.
Oh,
if you,
it doesn't reset
it. If you encode the slash as %2f and you set your cookie,
it makes it longer
to have a %2f then instead of slash, then that will inflate the size of your cookie.
Can you do
path.
//
I tried that. You can't do it. It won't send it. Which is annoying, but because there's like, it's almost like you're dealing with front end, back end within the browser itself, because it does normalization of those path of the browser URL before it actually compares it to the path. So I tried to do like path traversals and like dot traversals and stuff like that, but the browser's like, no, it's not going to happen. So you have to, as far as my research went, you have to take advantage of a discrepancy between the way that the server is parsing the path and the way that the browser is parsing the path, and then set your cookie in conjunction with that path. Does that make sense?
Yeah.
Yeah. So you can actually get your cookie
very,
to the
very niche.
very front, very niche. But that's what we talk about here on the pod.
Or you can just have it be sort of the same specificity, like the same level of specific, and somehow make it refresh the cookie.
Yeah, that's true.
And the sort of trick with refreshing cookies to get them to the end is the same thing I did back when I tried to comment cookies with the extra quote, the hanging quote, and I had a bunch of cookies that had quotes in them that were interfering with that. So what I did, first of all, I tried to predict the value of some of these cookies and set it without quotes. Okay, myself before the attack. So now the server is gonna see when it tries to set the cookie, it's gonna see that the cookie is already set with the correct value, and it's not gonna set the cookie with quotes. Okay, so that like eliminates those that I can predict. And I had one cookie that I couldn't predict the value of, but I found some endpoint that would reset the value of that cookie, like update it. So when I make the victim, or when the victim naturally interacts with that endpoint, that cookie is gonna get like popped to the
to the end of the string.
To the end of the string. And
because
then,
it's the newest set.
Yeah. And then I'm gonna have like my hanging quote, and then it will quote all of the important cookies up to that cookie that's at the end, right?
This may, it sort of reminds me of those scenarios, those double injection reflected XSS scenarios where you have a limited character set and you need to have 2 injection points. And you know, or maybe even if you're doing something, this is more applicable if you're doing like a dangling markup attack, right? Where you're leaving it open and the rest of that stuff is getting put into an HTML attribute. We're using sort of similar logic here to comment out cookies that are preceding or after our malicious inputted cookie, right?
What's more fun is the scenarios where you have the same injection in two places. And then you have like a dangling markup. And then that same character closes that markup in the other payload. And it's
my gosh, dude. Yeah, that gets very intense. And you can do like comments and stuff like that too.
Yeah.
And when we were prepping for this, I was thinking about this whole scenario. And I think I figured out a really, really helpful way to get to use these sort of gadgets, right?
That was a great way.
It's pretty great.
I really like that one.
I'm excited to tell people about this. Okay, so here's the idea, and I'll go ahead and share my screen here, so people can see the actual representation of it right here. And so essentially, the way that we utilize this is we have the ability to set an arbitrary cookie, right? And that cookie, wherever it is, allows us to set whatever value we want. So we have complete control of the value of the cookie. And so what we can do is make the first value, the first character of that cookie equal to the double quote, right? Which will trigger this weird double quote cookie functionality that's present in a lot of Java libraries and some Python libraries as well. And so that will now make the characters like semicolon non-terminating for these cookies. And then what we can do is leave that string open and set another cookie with a path that aligns it right after this cookie, and that also has the double quote on it, right? So now we've quoted the beginning of that cookie into of the second set cookie into that first cookie. And then from there, what happens that's really cool is the value of that cookie that we sent before becomes the key for another cookie. So we can convert a scenario in which we have control of the cookie's value, but not the cookie's key, into a scenario where we can smuggle an arbitrary cookie into the browser context, which is a much more impactful gadget.
Yeah, and there might be other ways to do that. There has been some research in that area. I remember there's one that you linked here, but I think there was another one. Maybe it was the one that was one of the top 10
top 10. Yeah, I think I
remember something too. Like that. I'm not 100% sure, but that's something that I will look at after this episode. But and one very like practical attack scenario for the trick you just mentioned is if you have what's called like a partial cookie injection. So you have, let's say in JavaScript, an injection into a cookie where you can only control the value, but you can inject like semicolons after it and control like a few attributes. Which we're also gonna talk about that scenario in a second. In another context. But if you have that, then you can set like the cookie that you want first to come first with the like dangling markup. You can set it and then specify a specific path that will make it come first. And then you can set your cookie, right? And it will be set like after the session cookie was set when the user logged in, right? So you will set it with like a double quote. You will set it without a specific path or with a less specific path or something like that, depending on where you want it to end up. And then you have like, you have two things. One, you have an injection of a cookie with whatever name you want, right? And I think that's possible because one thing that might trip you up is do you have to, in that case, inject a semicolon somewhere?
For segmenting off the cookie, or are you talking about?
Because you have like the opening markup,
Yeah.
And then in the second cookie that comes after, you have the closing markup. But I'm not sure if you can put like another cookie straight after it, or if you have to have like a semicolon.
Are you talking about in the set cookie header, or are you talking about the way that this
No,
is being
in
represented from the server? When
Yeah,
it's sent
the
to
way
server?
the server is parsing it.
Yeah, you do need the semicolon. There's some research, and it's actually in that same blog by
Because then
Ankur
I'm not
Sundara.
sure. I'm not sure that is possible, but what will be possible is to set like a dangling markup at the start and with a very not specific path, dangling markup at the end, and then you'll have like a cookie with a name that you control, having like the victim session token and all of that.
Yeah.
Even if they're
and you
HTTP
smuggle it
only.
into a different
which
cookie.
is mentioned in the blog that you linked.
Yeah, by Ankur Sundara, and we'll link that as well.
Yeah.
There's a lot of very interesting takeaways here. But
it's a great area of research because the parsing is just so different between the client and the server in this case.
It really is, and it's a pretty niche scenario where you have this sort of double quote thing, but Java is used a lot, and there's a good amount of Python libraries too. I want to say the research by Sundara mentioned that, CherryPy, web.py, AIO, HTTP server, which is used oftentimes, and a bunch of other ones will parse these double quotes.
The quotes.
Yeah.
Interesting.
And so we're talking about Python and Java environments here in a lot of ways. So this could be one of the things we could maybe build an extension for and see like, okay, we've got our session token or whatever, right? If we double quote it, does it still have a valid session or does it not? And that could determine whether or not we have that double quote gadget.
I think I figured out how we can smuggle and just like a cookie use a partial cookie injection and turn it into a full cookie injection where we control the key too. Just with like a partial cookie injection. So you'll need to inject 3 cookies, right?
Matan, what are you doing, man?
Okay, first cookie we'll call it first equals, and then just like an opening quote, and you put that at the start. Right after that cookie with a bit less of a specific path, or maybe they can all be the same specificity, you just need to set them one after the other, chronologically. So right after that cookie, you'll set second equals, and then just a closing quotes, right? Oh, wait. No, that might not work. Because then...
It should work. The double quote will be a part of the value because it isn't at the beginning.
Yeah, but I thought about using like the semicolon that sort of ends that cookie. But then we're back when we started because the third cookie that we'll inject after that closing quote we will not have control over its name.
I think it should. I think it should work with just 2 cookies, right? Because I'll
but
type
then
it in.
you'll have to. But
I'll type it in the doc. Hold on, Matan. Hold on. Let me type it in the doc really quickly, and then I think this should work. So let's say we have a cookie x equals double quote, right? And then we whatever, and then we set another cookie which is y equals double quote or like a double quote, right? Or whatever, right? So now this middle area right here, this is the value for x.
Yeah, but I think
or this is actually going to be
everything that comes
x2.
after that might still be part of x.
No, it because we can put the semicolon here.
I don't think you can inject a semicolon in the value of a cookie because then you will just be able to do like x equals a semicolon and then whatever you want, right? You won't even need to have the quote stuff.
Oh, you think the browser isn't gonna?
Yeah. Otherwise, you won't need to have the quote stuff anyways.
So then we have to rely on what Sundara was talking about with
with space or something
with
like
spaces or with some other delimiter, which is only happening in a very limited subset.
We're figuring this out while we're recording the episode.
But, we are.
So we're getting a very raw sample of the process.
Yeah, that's great. Okay,
we thought we got it like 3 different times.
Yeah.
Now we're pretty sure.
So then the browser is going to dang it, dude, this is so close. But I feel like there's in some scenarios there will be a way that you can actually result in.
I think some of the parsers will see my intuition is some parsers will see like the closing quote and will think like, oh, that's the end of that value. Now here begins another cookie, right? And in those cases, you will just be able to inject more cookies.
I think there were two scenarios where that was the case.
In Java,
Sundara's
it doesn't
research.
work, at least on the targets that I've looked at.
Okay, solid. So there's a very niche scenario then coming off of all this where you have to combine the double quote parsing with some sort of loose representation of what a terminator of the cookie value is,
right,
in order to convert a partial cookie injection into a full cookie injection.
Yeah.
Nice.
Very gadgety stuff.
Very, very gadget heavy stuff, as we always do here on Critical Thinking.
Yeah, I love it.
Okay, solid. Well, it's an interesting approach nonetheless, and the gadget I think is really useful because you control the order of cookies too with the path attribute. If you can just comment out the rest of the cookies with the double quote, right? Because you can do the same sort of thing with what you were talking about, where you can in 2 episodes ago, right? At this point, where you can just make a different person authenticated for a specific endpoint and
that was very cool.
comment out all the other cookies that might cause a problem. I think that's a really good way to approach this as far as exploitation goes.
So talking about commenting stuff.
Okay.
Great segue into the next section.
Let's do it.
There's a very weird behavior. Maybe it got changed since the last time I tested it. I don't think it did. This is a behavior in Safari, which, by the way, I've recently got a nice way to debug Safari stuff, because I don't have a Mac, and I tried to buy like a very old Mac to test Safari on specifically because I knew Safari just had too many quirks, but that was very, very slow. So what I did, and I very recommend it, I highly recommend it, I enjoyed it. If you have an iPhone, you can connect that phone. You have to install iTunes on your computer, but you can connect that phone to your computer, enable debugging on your phone, and then use some Google tool. I think it's called Debug Webkit Proxy or something like that. Debug Webkit Proxy. And iOS WebKit Debug Proxy, right? I'll drop the link in the episode, in the notes. But you can use that tool, and it will connect to the phone. And now you can use DevTools front end, and you need that to use the Safari DevTools front end. And there are some people that have like extracted that front end from the WebKit source code. And so you can have like a Windows version of it. And now you can basically have remote debugging on your phone without a Mac.
Okay, so this is a way for you to test Safari related bugs on just an iPhone. And it's kind of like remote debugging for Chrome DevTools, but it's specifically for Safari. Nice.
And so it's very useful to test this sort of stuff, and you can like interact with it physically, and you use like the same computer, and you don't have to move to a different setup. Anyways, the one very weird and quirky behavior I found in Safari is that we had, actually it was a collab with you, we had a specific ended very tragically, but anyways, we had an injection into the value of a cookie, and we could insert like commas, or what's it called?
The semicolon?
Semicolon, yeah. I forgot what it's called. But we could insert semicolons and insert attributes.
So we have like cookie attribute injection.
The problem was that we had other attributes, like the path attributes and all the fun attributes that we wanted to specify. They were specified in the sort of original statement that we were injecting into.
In the middle of
the way it works, attributes, the browser specifies the last occurrence. So we needed some way of commenting out all of the attributes that came after our injection point. And I found that in Safari, if you inject a weird special character after after your injection point, so you just go comma path equals something, comma, and then your
semicolon.
Yeah, semicolon. Sorry, semicolon. Your path equals something, and then semicolon, and then the character. I found that the closing curly bracket works. I think other characters would also work, but yeah.
Absolutely insane.
Super weird. And then it will just ignore all of the rest of the attributes, which it's nuts. I mean, I would think that if such an error occurred during parsing, it would just ignore the whole cookie setting statement, right? Throw some error or something, but they sort of sweep it under the rug, and you have like this sort of half error that causes very weird behavior.
That just comments out the rest of it. It's almost like a JavaScript, block comment or whatever that just comments out the rest of the...
But I mean, crazy. Even a block comment, you can't just like put it in there. Like a block comment, you need to close it out somewhere, right?
Yeah. It's nuts, dude.
Yeah.
That and it's crazy that it's such an unexpected character as well.
I mean, I tried to fuzz it a little bit. And this is just the first one I found.
The first one that hit was the closing curly bracket. Yeah, it's very niche, but it's really helpful. And what was weirder to me about this situation is as we were collabing on it, we were like, we need a way to like get rid of these attributes that are on the end so that we can do the cookie tossing properly, blah, 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 blah. And I remember the moment.
Oh, we combined the two. We combined the two things here, right? We did both the quote and the nice.
And you turn to me and you're like, I bet Safari has some weird shit with this. And I'm like,
you know why I did that?
How do you know that, Matan? Like, what?
Like a few days before that, I was collabing with Johan on some stuff in one of the targets that we hacked together, and it was like on a specific like context in JavaScript, and he just noticed because he has a Mac, he just noticed that Safari has a certain global variable accessible that other browsers don't in that case. And I was like, it was very weird and unexpected. And it sort of made me think about all the other bugs that I missed that were exploitable because of a weird Safari issue.
Yeah, man. Safari's whack.
That's why I decided to test it. I bought a Mac right after Johan discovered that little trick and haven't used it, but yeah.
Pays for itself immediately when you find all these weird little things that allow you to exploit these edge cases. Yeah, man, that is one of the things. I'm glad you mentioned the piece about being able to use that debugging on the iPhone, because that is one of the things that I'm a little bit sad about. Yeah, about not having a Mac is like you can't test weird stuff with Safari. And I've tried using, I think it's called Browser Stack. They will like give you a VM or whatever. No,
that's very annoying though. They're super expensive and there's always a delay.
Yeah, and I set it up. It was crazy because I set it up and I was like, wow, this is amazing. This is so easy. And they give you like 1 minute of free time. So I'm like rushing to try to like fuzz something really quickly.
I did the same.
And then, the fuzz is running and then it's shut down. And I'm like, no.
By the way, we're such weird consumers. I assume we're one of the only people that have like, we're unable to debug Safari as why we said we don't have a Mac.
Absolutely, man. Yeah, I think it might be worthwhile to just, it's definitely worthwhile to just have an iPad or an iPhone or something like that you can connect to and then use this debugging tool. But it may just be worthwhile to get my hands on an old Mac just to play around with Safari stuff for sure.
Yeah.
Okay. Was there anything else on that? So we've sort of got a way, a very niche way to convert a partial cookie injection into a full cookie injection. And just using this concept of the double quotes. And we have a way to comment out stuff in a specific set of web servers. That was the first thing we talked about. And then we've got a specific niche in Safari, which is when the cookie is coming back from the server side in the set cookie header, where you can comment out some of the attributes. Is that an accurate summary?
Yeah.
Okay.
And there isn't anything else in the doc, but if you want, we can do a redacted report section.
Yeah, well, we can do that, but let's go talk about some of this stuff that popped up with Mizu and this CTF this HeroCTF 6 because this was crazy. I'm not a huge CTF guy, but there's so many nice gadgets that come out of CTFs.
I mean, I'd love to do that, but I don't know how I can find like the actual useful CTFs because that aren't just another reflected XSS challenge. Mizu, you gotta just hit up boy Matan here whenever you create a CTF. Whenever you find a cool challenge or create a cool challenge, just send a link to me. I'd appreciate it.
Yeah, for sure. And the community can do that too. Just send Matan if you see a cool CTF.
I don't want to just say tell the community DM me.
Yeah, dude, you're about to get swamped.
Read my notifications, but
rip, dude.
Yeah.
But yeah, that's what you signed up for, man. It's already out there. Can't take it back. So I'll let me talk about the interesting caching. We're going to talk about two caching related functionalities from this write-up. That are gadgets that can be used, and then we'll call it a wrap because there's a bunch of stuff in here, and we're running long today. But let me go ahead and share this write-up so we can get it on the screen for those of you watching on YouTube.
I mean, this episode is only 30 minutes.
Yeah, that's
currently.
Okay. It should be fine. I've got to bounce in a little bit, but we'll go through this. The first one that I kind of wanted to talk through was this write-up called Medium Cache. And essentially this reminds me of a vulnerability that that's had several iterations that's mentioned here by BitK, where you're essentially utilizing the force cache attribute of fetch to pull data out of the cache that you wouldn't normally be able to access by doing a normal fetch request. And the situation in which this is exploited is really niche. And it's made more difficult now by the double key caching or cache partitioning that was implemented in Chrome a while back, I think in like 2019 or 2020. But essentially nowadays, these cache keys are generated via three parts. It's the top level window, the current window ETLD+1, and then the full URL of the loaded resources, what lands into this cache. And the way that this is abused in this specific scenario is related to how fetch is not allowed to send credentialed requests to an endpoint that has access control allow origin star. You'll get an error if that's the case. So what is abused here is the solver of the CTF puts an image tag in with a source pointing to the specific resource that they want to leak, which cannot start with a curly bracket, is noted because of Corb. But that will actually load that specific resource into the cache. And that request will be sent with the same site none cookies sent along with it. And then you can load that request from the cache using the force cache setting in fetch, and then read the response, which you normally wouldn't be able to do because fetch can't send credentialed requests to an access control allow origin star endpoint. So essentially, you're priming the response with the image tag that has the access control, and that ignores the access control allow origin star thing, that you don't get any errors there. And then you bypass that by using the fetch request to load the response directly from the cache. And since it's access control allow origin star, you'll be able to read it. And that response, which was created and cached with the same site none cookies from the image. Matan, I don't know. Can you check me there? Was that explanation
that
too?
Was that was accurate.
He says that was really something, Justin.
We were just recording for so long, I forgot how to say accurate.
Yeah, I'm sorry, dude. I'm sorry. Well, are you up to doing the what do you think about this one?
No, I can still record. I just if we'll keep going, I'll need a short break. But
you're good, man.
Yeah.
Do you want to?
It's very interesting what happens here because you have like the image which sort of sends a request with credentials, but that you cannot read, right? Similar to a fetch with mode no course, right? Which it would be interesting if you can actually use that instead of the image. Maybe no cause force cache. Maybe, I don't know. But you have like a request that you can send with credentials but cannot read the response, and the request that you can send without credentials but read the response. And you sort of combine these two so that the second request will actually get the response of the first one from the cache. Very interesting. I've never thought about it.
Yeah, and I think they exploit it in this specific CTF environment under a more nuanced environment, because some of the cookies are set to strict and require, it requires a gadget, an XSS gadget on the website. So you're sending this from a same site environment. But I think this is also exploitable in Bug Bounty in the wild, in environments where there's same site none, but you're running into that access control star problem.
Or in environments where there's same site lacks or something, and you have like subdomain XSS.
Yeah, well,
It's
that's
pretty
actually
common.
it's an interesting point too, because I think at the bottom of this write-up, there was an unintended solution that somebody found that uses window.open, and it does window.open to that, which is actually a top-level navigation. So I wonder...
Oh, and that stores it in the cache, huh? Yeah, makes sense.
Huh.
So
I didn't test that.
Would the browser... but then when you do window.open, you mentioned the 3 cache keys, right?
Yeah.
Then the cache key of like the top level URL or top level site, right?
Yeah.
That would be different between the request that you want the cache for and the request that retrieves the cache. Because one of them is going to happen from the attacker side, and the other is going to happen when you load the window. And in this case, because it's a navigation, it's going to be... you see what I mean?
I do.
Yeah.
And it's
So-
ETLD +1 though. So
it will probably cache it, but you won't be able to retrieve that cache cross-site.
right, you'll only be able to retrieve it same site.
But
Okay.
how was it different in this case? I mean,
Dude,
I think I'm correct, but
No, you are
maybe
correct.
not.
It's because it's same site and the cache
So
key
what was the
works.
unintended solution in this case? Why did it work?
It worked because it's via an XSS. So
They still used that gadget. So
They did,
it's the
yeah.
same prerequisites and the same impact. So
yeah, exactly. So that doesn't actually, that would have been crazy though, if you could do like a
Yeah.
top level navigation and then bypass the
it's such
same
a
site.
weird
lacks.
little attack surface here. And I mean, I have thought in the past about, actually quite recently, about what happens when you have an injection into like a fetch call. So basically you can specify like a URL, maybe with some restriction or something, and a bunch of options, but you can't read the response. Can you somehow use the cache in that case? And
That's a tricky one, man.
aside from cache poisoning, maybe you have like some header that isn't in the cache key of like the browser.
Yeah.
So that's sort of client-side cache poisoning, if it makes sense.
Yeah, that does make sense. That's super
Then
neat.
to be clear, what I'm
That's
talking
amazing.
about here
Yeah.
is, I don't know, some post message listener on example.com just injects into fetch, right? Accepts 2 parameters, injects both of them into fetch. Then from attacker.com, you send a post message that goes to /example.com/reflectheader.php and have like x-xss : and some HTML injection payload, right?
Yeah.
And so the post message will be like, the first argument would be that URL, and then you will have like in the options headers, and then specify the headers and cache mode or cache : force cache, not cache mode.
Yeah.
And I think what that would do, would the cache key of that like malicious response or response that contains HTML would be the example.com as the top level window, example.com as the current window, and example.com /reflect
As the,
yeah, so
as the
so
key.
then so /reflect header. So then when you initiate a top level navigation to example.com/reflect header.php, it would be the exact same cache key, right? Because it's still under example.com, still under example.com in the current window, and still the same URL.
Dang, dude. That's interesting.
Yeah.
Huh. Wow.
And I had that theoretical, but I didn't know, like, it was maybe 2 days ago. So weird occurrence that I've actually...
all of our episodes, like the longer they go, they degrade into like, this is just us doing research live on the podcast.
No, but I mean, it's an idea that I had like maybe 2 days ago, which is crazy that all of this research comes out like
right after
a few days after that. But I've thought about it, and I didn't actually have such a gadget with header reflection when I sort of
when you went after that,
when I went after that, but so I didn't actually test it. But now that I actually understand how the cache keys work, I don't see a reason why not.
That makes sense, dude. Wow. Well, you've got a week and some change before this episode airs, so you gotta go knock that out.
No, I mean, first of all, nobody's gonna know which target that's in.
Right.
Second of all, I'm pretty lazy, so maybe not. I'll do it next week.
Somehow I don't buy that, Matan, considering.
No, I mean, I get a lot of bugs, but that's still
a different scenario, I guess. Okay, so let's talk about this cache put thing, and then we'll call it a day. So as I understand it, the situation with this was that there's this caches object that is being exposed on the to the actual page that's normally used by service workers. And this is, for those of you following along, this is in the service worker pipe hijacking through cache API section of the mizu.re write-up. And I'll go ahead and share my screen for that as well. And essentially,
what a domain name.
I know, right? Essentially, on this one, as I understand it, this allows you to take an XSS that you have on a specific page and use that to hijack any sort of caching done via service workers on the domain where this XSS triggers. So you can get XSS across a lot of different endpoints and stuff like that using this technique. Is that, I mean, is that an accurate representation there, or am I misunderstanding?
Sorry, I didn't
follow. No, you're good. So if we do caches.keys, right, on this specific scenario.
You mean the service worker scenario?
Yeah.
That one was also very cool, because the caches API, the sort of main use case for it is when you have a service worker that tries to implement a cache. Right, and it sort of gives you more control over it, because you can manage the cache keys and the response and the responses associated with them very directly in the service worker. So the normal usage for this is you have a cache. So the way you get a reference to a cache is you go caches.open and then pass some string to it, which is the identifier of the cache.
Okay.
And then you get a reference to it, and you can add requests to it and responses. An interesting thing is you can use this API as a sort of alternative to fetch. So it has a function. If you go to the if you have a reference to a cache, you can go cache dot like that cache variable dot add, and then pass a request object to it. And then what it will do is it will automatically issue that request and store the response in the cache. And then you can just retrieve the response. So I had a scenario somewhere where I didn't have access to fetch, and I used that to
as
sort of
like
get
a fetch
around
alternative.
that.
Interesting.
Caveat is it will not send post requests.
So just forget. So that could be a way if you don't have access to fetch or the XHR request or whatever.
In some like very weird scenario.
Sandbox environments or something like that.
That's too specific. I didn't want to say that.
That is very interesting. So I think that the way that they used it in this scenario was to
anyways,
hijack the service worker, right?
Yeah. So if I want to get back to the to the explanation of the actual bug here, the scenario is if the service worker uses the cache API as like intended, just to store like responses, and then like when it matches a response in some cache, it will return it. What's interesting is the cache that I mentioned you open like with a specific identifier, and I didn't know that until now. It's sort of shared in the whole origin, sort of like local storage.
It's crazy. Yeah.
So if you from like even a normal page in that origin, which is sort of less privileged than the service worker, if you use caches.open with the same identifier, you can get a reference to the same cache and start manipulating it. And then you can add like a request response pair where the response has like a malicious HTML payload. And now if the service worker matches that in some request, hopefully top level navigation or something like that, so the response renders, then you will get XSS there.
Right.
I guess you can also
turn that whole thing.
I guess you can also like intercept JS resources, stuff like that.
Yeah, that's kind of the one that I was thinking of, is like, okay, this service worker is there to do caching on like, JS resources or other resources that might need to be reloaded a bunch of times. And so then by poisoning that response, you pivot your XSS to a much larger variety of pages.
Yeah, the sort of...
And make it persistent.
Yeah, that's the thing. A larger variety of pages is like you could always just window.open and do stuff with that because they're same origin. This is like a very weird attack scenario because you have XSS, which is usually like game over, but you're trying to escalate it further to make it persistent.
Yeah.
Which in some cases you will have to do.
Is very helpful, I think.
Yeah, say it's like they have some flow where when they authenticate a user, they only authenticate them in that specific tab, right? Say with session storage.
Yeah, or there's session storage. Right. Session storage is the one that came to mind for me because it's isolated to the tab.
Then you want to make your XSS persistent.
Right.
So that whenever they open any tab, they will get XSS. So the next time they log in, they will get XSS. So this is sort of a way to do that. Another way to do that would be maybe reflection of a cookie of local storage, stuff like that.
That's what we typically use.
That's very interesting though.
Yeah.
Because
this one's a little bit more widely applicable.
Very globally applicable. It's just, I have no idea how you're supposed to mitigate that. And even like from the Chrome perspective, because are they just gonna change the behavior?
They can't, because I'm sure there's legacy stuff with it. I think we've got this one on lock. I think we're gonna have this escalation technique for a while. Yeah. All right, man.
Very interesting.
We made
Great
it through
research from Kevin.
Some very long episodes, and I appreciate that you allow me to milk your brain for every last little bit of knowledge that I can get.
I'm still keeping some stuff, but I disclosed more than I initially intended to.
There we go. All right, man. Well, thanks for coming on, and I appreciate you as always.
Thanks for having me again.
Peace, dude.
Peace.
And that's a wrap on this episode of Critical Thinking. Thanks so much for listening. And if you want more critical thinking content, head over to ctbb.show/discord. Join the Discord. There's lots of great conversations and chats going on over there. And if you want to support the show, there's the Discord subscriber tiers, which give you access to masterclasses, AMAs, hackalongs, exclusive scripts, and an exclusive chat channel with us. We'll see you there.